Welcome back to another episode of How to Geometry, where I show you the finer points of geometry. In this particular episode, we're talking about special case right triangles, where Pythagorean theorem will always work, but if you can recognize that you're in a particular situation, and particularly where your right triangle has two 45-degree other angles, then a very particular rule can be applied, which I'm about to show you now. So hopefully you get something out of this and you enjoy it. All right, so hopefully by now we're comfortable with solving right triangles using Pythagorean theorem. We know that if we have two sides of a right triangle, we can always find the third side using Pythagorean theorem. However, there are special cases where if you recognize that you're in a specific right triangle case, then Pythagorean theorem isn't necessarily necessary. All right, so let's just say that we have a right triangle. However, this particular right triangle, an isosceles right triangle, where the two legs are equal in length. This means that the angles opposite of these legs must also be equal. That means this angle would be 45 degrees and the other angle would be 45 degrees. And obviously the right angle is 90 degrees. We know that a triangle has to have 180 degrees. So in this very particular right triangle case, there is a technique to where you don't have to do Pythagorean theorem. So if I have this situation, then if I know one of the legs, I can for sure find out the hypotenuse, and vice versa. If I know the hypotenuse, then I can figure out the lengths of the legs. So let's see an example, see if we can figure this out. So very basic. If the legs are 1 unit, the hypotenuse would be 1 squared plus 1 squared is equal to c squared. We see that this is 2c squared, square root of both sides. C is equal to root 2. So here the hypotenuse would be root 2 in a right triangle that has legs side 1. Let's look at the similar triangle with side lengths 2. This would be 2 squared plus 2 squared is equal to c squared. 2 squared is 4. 4 plus 4 is 8. Square root of 8. So 8 can be simplified. 2 times 4. 4 is a perfect square, so I can bring out a 2. So c, the hypotenuse in this case, is equal to 2 root 2. So first example, c is equal to root 2. Second example, 2 root 2. The hypotenuse, that is. All right, let's look at a third example, and hopefully we can recognize some pattern. Okay, if we had side lengths 3 in a similar right triangle, 3 squared plus 3 squared is equal to c squared. It's going to be 9 plus 9 is equal to c squared, which is 18. Take a square root of both sides. This is going to be 18 can be reduced or simplified rather to a 9. We can bring out a 3. So 3 root 2. All right, so see there's a connection that we can make between the legs and the hypotenuse. Depending on what the legs are, the hypotenuse is going to be the measure of the leg. The hypotenuse is going to equal the measure of the leg times root 2. So in a 45, 45, 90 triangle, right triangle, the hypotenuse is going to be the leg times root 2. All right, so let's see another example. All right, in this right triangle, we have a leg that is 12 root 6, and we want to find the hypotenuse. So let's apply the idea that we just learned, right? So the leg, 12 root 6, times root 2. This should give us the hypotenuse. When we're multiplying radicals, it's the outside times the outside, and then the inside times the inside, essentially. The radicand times the radicand. This would be 12 root 12. 12 can be simplified. 2 and 6. 6 can be simplified even further. 2 and 3. And then we can bring out 2, which is going to be multiplied by the 12 that's already out. And then the 3 stays inside the radical. So y is going to equal 24 root 3. All right, so a very useful tool is that if I know either leg, I can always get to the hypotenuse by multiplying by root 2. Likewise, if I know the hypotenuse, I can get to either leg by dividing by root 2. So let's see an example of that. All right, so in a right triangle, 45, 45, 90 right triangle, if the hypotenuse is 7 root 3, the leg would be, one of the legs, or technically both legs would be 7 root 3 divided by root 2. All right, when you're dividing a radical, or when you're dividing a square root by a square, when you're dividing a square root by a square root, we don't like square roots in the denominator, so we have to rationalize the denominator. So I'm going to multiply the fraction by 1, right? Because I can multiply 1 times anything and not change the value. So the trick is that whatever radical is in the denominator, I'm going to multiply that fraction by that denominator, top and bottom. So the bottom is root 2, so I'm going to multiply by root 2 over root 2. All right, and we multiply straight across, top times top, bottom times bottom. So root 2 times root 2 in the denominator. Another little trick is that when you're multiplying square roots and the radicand, the part insides, match, then the answer is just the radicand, the part that's inside. So root 2 times root 2 is just 2. Up top, outside times outside, which is 7. And root 3 times root 2, which is 6. So the leg for this particular triangle is 7 root 6 divided by 2. Nice little shortcut. So instead of having to do the Pythagorean theorem every time, if you can notice that you're in this particular 45, 45, 90 situation, it does make a good shortcut, so to speak. All right, so let's see some more examples. All right, in all of these examples, it will be a 45, 45, 90 triangle. So if one leg is 5, the other leg must also be 5, and the hypotenuse is going to be the leg times root 2. All right, if the hypotenuse is 7 root 2, and x and y are the legs, let's figure out what the legs are. So 7 root 2 divided by root 2. So the nice thing here is that root 2 is in the numerator and the denominator, top and bottom right. So root 2 can cancel. And so the legs are going to be equal to 7. That's nice. So we'll do a couple more, and hopefully, because this gets really repetitive, hopefully it becomes obvious. That's the goal, right? Is that it's second nature. When we see it, we just know it. So here, if this was 9 root 2, the legs are going to be 9 root 2 divided by root 2. So the legs are going to be 9. Okay. In this particular triangle, if x is the other leg is going to be 32. Right, because in these particular situations, the legs are equal. The hypotenuse, the longest side, is going to be the leg times root 2. So here, y is going to be equal to 32 root 2. All right, so I feel like this is sufficient enough. Um, Hopefully this comes in handy. Hopefully you use it and got something out of it. So if you haven't already, please subscribe, comment, like the video, tell me what you think, and I'll catch you guys in the next video.